Hello, Cisco instructor Andrea here. So we've already learned about binary in the base 2. We also talked about how to convert a binary number to a decimal number. Today I want to talk about how to convert a decimal number to a binary. Again, this is one of those things where we just have to learn it because we're going to be doing subnetting, VLSM, looking at subnet masks, and things like that. So this skill is something we need in order to do that. We're going to use a decision tree or a chart similar to what we used when we converted something from binary to decimal, when we do decimal to binary. So let's take a look and assume that we had an address, an IPv4 address of 200.100.64.2. These are the decimals, so we have to convert that to binary. The way we would use this chart is we'll take the decimal value of 200 and write it in here, because the number 200 is what we have to convert to binary. By now, I'm hoping this is starting to look familiar. The bit values 1, 2, 4, 8, 16, 32, 64, 128. We have 8 positions, we have the bit values, and we know this to be what? An octet. All right, the way this is going to work is we're going to look at the bit value, starting with 128, and ask yourself, can 128 be subtracted from 200? Or will 128 go into 200? If the answer is yes, then that bit value is turned on. 128 can be subtracted from 200, so my bit value is 1, or my binary equivalent is a 1. 128 from 200 equals 72. 72 is my remainder. The next thing I do is I ask myself, can 64 be subtracted from 72? The answer is yes. So I know that this binary is on. So 64 from 72 is going to equal 8. The next thing I do is I ask myself, can 32 be subtracted from 8? The answer is no. So that means that my binary is off right here. My binary is off. What do I do when the binary is off and I can't subtract the 32 from the 8? Then I just need to bring the 8 down. And I do this same question. Can 16 be subtracted from 8? Will 16 go into 8? The answer is no. So this binary is off. I bring the 8 down again. Now I ask myself, can 8 be subtracted from 8? The answer is yes. So this binary is on. 8 from 8 equals 0. So my remainder is 0. Can 4 be subtracted from 0? No, it cannot. So my binary here is 0. I'm just going to bring the 0 down. Can 2 be subtracted from 0? No, it cannot. So my binary is 0. I bring the 0 down. Can 1 be subtracted from 0? It cannot. So that's 0. I just bring the 0 down. Now I've ended up with my value, my binary value. 1, 1, 0, 0, 1, 0, 0, 0. So if I figure and go backwards, I have 128 plus 64 is 192 plus 8 equals 200. So my binary equivalent for the number 200 is 1100, 1000. Let's figure it out for the next octet. So if I'm still working with 200.100.64.2. Now let's solve for the second octet the value of 100. I'm going to do the same thing. I'm going to enter my 100 right here in my decimal number. Can 128 be subtracted from 100? It cannot. My binary is off. So I'm just going to bring the 100 down. Can 64 be subtracted from 100? Yes, it can. So my binary is on. I bring my remainder down, which will be 36. Can 32 be subtracted from 36? Another way to say that is, will 32 go into 36? The answer is yes, so I know that my binary is on. 32 minus 36 is 4, so I carry the 4 down. Will 16 go into 4? No, it will not. I just carry the 4 down. Will 8 go into 4? No, it will not. I carry the 4 down. Does 4 go into 4? Yes, it does, so I know that my binary is on. 4 minus 4 is 0. So I only do the math and figure out the remainder when I can actually subtract one from the other. 2, will it go into 0? It will not, so my binary is off. I bring down the 0. Can 1 go into 0? It does not. I just bring down the 0. What's my binary equivalent? 0, 1, 1, 0, 0, 1, 0, 0. Okay, so where am I at so far? So far what I've got is 200, which is 1100, 100, and I've got my 100, which is 0110, 0100. I'm going to go ahead and figure out for 64 and 2 as well. Okay, so now let's look at 64. Does 128 go into 64? It doesn't. I bring down the 64. Does 64 go into 64? It does. So I turn it on. 64 minus 64 is 0. Does 32 go into 0? It doesn't. Now from here we can see it's always going to be 0 because nothing is going to go into it. Does 16 go into 0? It doesn't, so it's off. I carry the 0 down. Does 8 go into 0? It doesn't, so I turn it off and I bring the 0 down. Does 4 go into 0? It doesn't, so binary is off. I bring the 0 down. Does 2 go into 0? It doesn't, so I turn the binary off and I bring the 0 down. Does 1 go into 0? It doesn't, so I turn it off and I bring the 0 down. So that one went pretty quick. I've got 0, 1, 0, 0, 0, 0, 0. So where am I at now? I have 200, which is the 1, 1, 0, 0, 1, 0, 0. My 100, 0, 1, 1, 0, 0, 1, 0, 0, dot 64, 0, 1, 0, 0, 0, 0, 0. And lastly, we're going to do the 2. So I'm still working with 200.100.64.2. And I'm putting 2 in here. This one should be fairly easy as well. I do 128 into 2. I know that's going to be a 0. This one's going to be pretty easy because I know all of these bigger numbers, they're not going to go into 2. So I know this one is off, 32 off, 16 off, 8 off, 4 is off. Okay, so I'm just always carrying the 2 down. It isn't until I get down to the 2 that I've got some action. 2 can go into 2, so this one is on. 0, does 1 go into 0? It doesn't, so it's off. My binary equivalent this time, that's an easy one. And if you think back to our positional values, right, we know that the positional value here is 1, the positional value here is 2. So it's easy to see how we can write the number 2 in binary. So finally, let's figure and finish up our IPv4 equivalent. 200, 100, 64, and lastly, our 2. So there is our binary equivalent. So we've learned about binary, the powers of 2, how to raise the base 2. We also converted binary to decimal, decimal to binary. So we can write an IPv4 address now in binary or decimal. Thanks for listening.